I think that I've answered on the second question, but if I have 1 or 2 minutes, I could share something. When I prepare myself to come here, my colleague asked me to share their opinion. And their opinion was quite clear. They are not sure about the exactness of this climate hysteria or this CO2 goals that European Union has to achieve. So, is that the right goal that European Union has to achieve? I don't want answer from you. Just think about it. And if this is a goal, the nuclear energy has to be put in an important role, because, as you know, in a very recent document from European Union, you know that European taxonomy, nuclear energy was included once, but is not mentioned as a sustainable source to develop our society, to develop our energy mix. And this is the main answer of the conference, how we will achieve the transition. I'm not sure that we have to make a transition, but it's my opinion. And finally, during our visibility study, we've made a very deep risk assessment. And I would like to share 2 main risks that we identified. First of all, we are losing nuclear knowledge because the old people are retired, and the last unit were built 25 years ago. So we have a big problem with the nuclear knowledge loss. And a second risk that we identified is the lack of interest of young people to go to study physics, chemistry, and all this tough and difficult discipline. Everybody wants to be lawyer and economist or other things, but nobody wants to. So this probably is connected to the answer with the safety cost. We have to work to attract young people to start learning physics and chemistry, and we will raise our safety costs. That's all for me. Thank you for the invitation.
So, thank you very much. I agree that we also in Finland had that kind of problems, that there has been too many years from last project in order to have all the capabilities with ourselves. And the young people are interested not physics and so on. I know from my experience that I don't know how we can attract them into the business. But I think that now we are discussing about the nuclear being a solution for climate change. I think that could a little bit enhance their interest into this branch. So, then let's go to the next topic, that will be the MANKALA issue that we have been discussed many times so far, and Juha Poikola from TVO has promised to tell something about that. So I'll just tell a little about the Olkiluoto 3 project, just to prepare for this. So TV is about to start the operation of the new EPR, and that will ensure 50% of electricity needs of Finland. So it will help us from our cold and dark days like tomorrow. So we really need that electricity in future. And it also increases the amount of decarbonized electricity, and the facility, when it starts, it will be in operation in 60 years. So we have many wonderful years ahead with that new facility. So about the MANKALA issue, so I think that many of us are curious to know what it actually means. I don't know if we know all that details, what it's all about. So please, the floor is yours, Mr. Poikola.
Thank you, Marjut. Thank you. First of all, just a comment to my Bulgarian colleague who had a wrong title, and he went away, but not went away, but just for hopefully coming back soon. About the taxonomy, so we have been wondering that a lot in Olkiluoto. because they have so-called expert group behind that taxonomy issue, and they are claiming that there's no solutions for nuclear waste. That's one of the arguments why nuclear is not sustainable, and so they should come and visit Olkiluoto. So we have a solution there, and we are building it right this minute. So, and the other countries will surely follow. So waste solution is not the issue. But about MANKALA, so can I ask from the audience who have heard about MANKALA, who knows the MANKALA principle? That's what I thought. There are more than 50% of the audience have heard it. So it is a success story. Yeah, you're supposed to know. It is a success story. And the history goes back to 1950s. So we've been operating with that principle for more than about 50 years. And now when Olkiluoto 3 has been a long project, so we have been testing this system quite many years. We have announced that the total cost of Olkiluoto 3 for us is 5.5 billion euros. And about 1/4 of that is equity, and about 75% is from the financial markets. And we are out there in the markets every year. So we are looking for more. We are refinancing our money yearly there. So we test how do the financial institutions think about MANKALA, and how do they think about nuclear power. And so we have been quite successful with financing of this additional money that we needed. So we have quite a lot of debts. We talk about more than 4 billion euros of debts, and of course the price of money is very important. We have a credit rating, so the credit raters are looking into this MANKALA system. Is it a good or bad system? And I think we have educated these credit rating and institutions and financial institutions, and now they know what it is, and they have a trust on the system. So it is a risk-sharing system. It's the way we can get the capital for these investments, and we have a long track record of doing that from year to year. But of course, it's not just nuclear power. Today it's about 45% of the Finnish production is financed with MANKALA, so it's a very important system. Getting back to the history, so we have the history of having a strong state-owned energy company, which is now today is called Fortum earlier. So, as most of the European countries have a strong state-owned energy company, but in addition we have lots of private companies, big ones. So there has been always options and competition within the power production. In the earlier days we had also transmission networks. We had two TSOs, but now they are combined to one. Of course, that's more rational. But in power production, this MANKALA principle has created a lot of competition. Because if you get the financing, if you can finance these investments, so you will get new supply. So it's good for the market. It's good for the customers in that sense to have this additional supply. But it seems to be a very domestic, very Finnish system. So it hasn't really. We haven't seen it anywhere else, really, in Europe or in the world. A bit similar systems are, of course, it's quite close to a cooperative. So, but the thing is, in the MANKALA system, you don't pay any dividends, you don't make any profits. So it's a zero profit company. We do it at cost. So in every comparison, if you compare energy companies, our figures are not that good because we don't make any profit. And but the thing is that, of course, we benchmark our performance on daily basis, and the benchmark is the Nordic market price. Are we competitive with that price? Are we bringing any additional value to the shareholders compared to the market price that you can benchmark every hour in the Nord Pool power market? And back to Olkiluoto 3, so if it's now, as you heard, so we had this new timetable, we will have a new timetable, so we don't know the loading month. It will be in operation next year, but we will see. We will give you more exact timetable in a few weeks. But it's a 11 years delay, and of course additional budget was much lower. So although in this difficult situation we have successfully been able to finance this project. So I think it's a very good proof that this risk sharing with MANKALA is working. That was shortly about MANKALA, and happy to talk more later on. Thanks, buddy.
Thank you, Juha. Now we are much more wiser in this subject. So, the last but not least, we have next the new technologies, and it's ROSATOM and it's SMR development work. So, Mr. Under Kozloduy. So, large-scale power plants are the traditional ones, and now they need also beside them the new technologies, SMRs, which is for remote areas and decentralized electric networks. And also the local people and communities has to retain the enthusiasm to this subject. So actually I have two questions for you. So how local energy demand, the structure of electric network and geography could be better taken into account with these SMRs? And there are new innovation, your floating reactor academic Lomosov that we all have heard from news, and it will be ready in network by the end of the year. So how do you see the future with this type of technologies in Europe?
Okay, thank you very much. First of all, Claude, thank you very much, Finnuclear. I think it's a great pleasure for all of us, to be here in Finland. And the way it was organized is very interesting as well, Thanks, Claude, for inviting other industries. I think it was very beneficial for us, to understand what they expect from us. Thanks for bringing new countries. I really enjoyed, speeches from Estonia, from Poland, from Kenya. It's very important for us, to understand, what countries positive towards the nuclear energy think about the future of that sector. And as well, I look at that sheet of interpretation channels, Francais, Espanol, Hungarian, English, It's for the first time I see that kind of list, you have so many languages. Thank you very much. And I will talk about not big nuclear power plants, but about SMR. And I think it's very wise, to have that discussion and in that country, in Finland. Specifically, I think every newcomer country should look at the situation in the nuclear energy in Finland and try to learn some lessons out of this, because, the way it was developed, is absolutely tremendous. And the panel, I think, and the way it's organized represents the current evolution of the demand in the energy sector. I think it's very important to have in mind that MANKALA principle, which exists only in Finland, and probably for SMR it's going to be a model, an economical model as well. It's very interesting, friend from Kozloduy NPP mentioned, we are the most probably effective in terms of energy cost, 25 euros per megawatt hour. It's quite attractive, I think, bear in mind, the current prices. But the new requirements in terms of the new project in Bulgaria, no state guarantees. And we all know that, always big NPP try to be related with the state guarantees, or at least PPA, power purchase agreement. And the new requirements basically reflects the market expectations. And what I would like to talk about is the market evolution and how SMR will respond to them. As well, interesting that there are two definitions of SMR, whether it's a small modular reactor or small and medium-sized reactor. So it depends on what you're looking for. And sorry, I made some slides, and if you don't mind, I can show it just to illustrate, what we're trying to do and how we try to respond to the local demand and with innovations. But basically, I'll try to answer your two questions by one presentation. Sorry, I'll try to move. Basically, it's a mistake because it's not the first slide I wanted to show. That's the first slide. And again, for the Russian nuclear industry, what is going on in Finland is very important for us, and everything we do somehow related to Finland. And I want to talk about the evolution of SMR at Russia, and that idea came from the experience we gained in using nuclear fleet. Currently we have 4 icebreakers in operation, and 2 of them were built here in Finland, type Taimyr and Vaigach. And basically the main driver right now of the development of SMR and floating NPP is the Northern Sea Route project in Russia, which existed for many years, but only now, it become officially supported by the Russian government. And in December 2018, the President of Russia signed a decree and named ROSATOM as an operator of the Northern Sea Route. And as a result of that, we have a tremendous program, to build new icebreakers and to develop the floating NPP fleet. Can I have the next slide, please? That's the example of the new icebreaker. We're going to have 3 new icebreakers. But if you talk about icebreakers, it's a kind of floating SMR. You have 2 reactors, and basically it's a civil application, but it can float, it can transport some cargoes, and use it to be used as a kind of nuclear power generation. Next slide, please. It existed as well a career of container ship, but it never been used widely. And why, as well, the first NPP, floating NPP, appeared because of the next slide, because of the development of LNG project, and the gas, liquefied natural gas, became a very important factor. And the biggest Arctic project we currently have is Total SPG, and we do that in cooperation with our French partners, Total and ENGIE, and that's the first probably big LNG carrier which will be which we use, and they use icebreakers, to deliver the cargo to its destination. Next slide. And that's the first of the kind floating nuclear power plant. Yeah, the name is Academic Lomonosov, and why it happened basically. You have Chukotka area, which is a very remote area on the north of Russia, close to the United States, and you have a lot of gold mines and a lot of coal and other mineral resources. And you have 4 small modular reactors there, a station called Bilibina nuclear power plant. You have 4 reactors, 12 megawatt each. And 3 of them work, and the capacity factor is quite low, it's about 50%. And they are supposed to be decommissioned. And that floating NPP will replace the existing nuclear power plant. And currently in that area, specific area, Chukotka, Bilibina, accounts for 80% of electrical subsystem, which accounts for roughly almost 40% of the whole electricity of that region. So they neatly pad that electricity source because the grid is underdeveloped and they don't have electricity to service their needs. So that's why it happened, and actually it follows certain demands, regional demands which exist. Next slide. That's basically the parameters of that, the new NPP we want to build. Because you, in academic Lomonosov, you have 2 different reactors. Here you have a new one, and the difference will be that it's supposed to provide heat as well. Because current Bilibina and NPP, they provide both. And someone from yesterday mentioned cogeneration. It's a very important factor. And what we should do, we should think about providing not only electricity, but as well heat and probably desalination for the, if that it will be required. So coming back from the floating NPP, next slide, please. There is a project, to build base land, small reactor. The key, I think, here is you have to follow the demand. That's why I think, the MANKALA principle is extremely important for us, because we want to use the same economical model, it should be organized by local communities. And thanks, Claude, again for inviting municipalities here, because I think they will play a key role in the development of SMR as well. And you see the same reactor. Why it's important? Because you can see that reactor in icebreakers. You can see them at academic in the future NPP and at the future icebreakers, and we're going to use the same reactor at the base. And next slide. I just wanted to share with you the plans. The same approach. We want to build them in Russia as a first of the kind, and then see how it works. Is it efficient enough, to be commercially proposed in other countries or not? And you have 3 regions. You see Yakutia and Bain deposit, quite remote, but interesting, in Sarayam deposits, it's an Ural region near a city called Chelyabinsk. And here we have the same project, there is a huge ore resources, and they need electricity, and they don't have enough electrical system, developed, to supply the demanded electricity. And talk with them about the first baseline NPP, SMR in Sarayam deposit. And the plan is to decide it on the place this year or next year. And the plan is 2027 to have commercial operation of that SMR. So why I'm saying that, I think it's critical, and I was very impressed by the presentation of my Estonian colleague that SMR, it's a bright future probably for some countries. But we shouldn't forget, for instance, it's not competitive. And if you talk about our personal case at Chukotka, you have quite different tariffs, and you have quite attractive price for SMR, and we can build them a plant, because electrical price, it's quite different of what we have in Russia, in the central Russia, I mean. And we have to improve that in order to make it competitive. And if you have the next slide, I use that goal, sustainable development, 3 killers. Not killers, but pillars. Economic growth. Basically, we have to be competitive if we talk about SMR, right? As well, social contribution is incredibly important. That's why I think, the MANKALA principle, we need, regional support is very important, and participation of municipality is critical. and obvious environmental, you know. Standardization of standards, as it was said, it's vital for that, you know, because we will not have licenses if we don't do that for SMR. So you have all these problems related to the exploitation of big NPP, but with a much smaller scale. So I have to deal with that. And if we manage to solve all these issues, you know, it could be successful. So, but don't forget economics, and that's going to be the most important factor for SMR. You know, it has to be competitive. So thank you very much for that attention. Sorry again for the presentation, but
nothing to say sorry about, because it was very good presentation and very illustrative. So thank you very much. So I think that we could have time for a couple of questions from the audience, if you have some, so please.